Alright, this video is about factoring out a GCF. And so let's start with what that means. So when we say GCF, we're referring to a greatest common factor. Okay, so just a quick review of those words. So greatest common factor means if I have two numbers, so let's say we're going to look at 2 and 6. So the greatest common factor of 2 and 6 would be the biggest number that I could divide out of both of them. Okay, and so like if you think about the numbers that will divide evenly into 2, that's only 1 and 2. If you think about the numbers that will divide evenly into 6, that's 1 and 6, 2 and 3. And so the biggest number that's in both of those lists would be 2. So 2 would be my GCF. Okay, or maybe if we looked at the numbers 8 and 12. So if I think about all the numbers that are factors of 8 or all the numbers that are factors of 12, I want the biggest number that would be in both of those lists. So you might think, okay, 2 goes into both. Well, it does, but there's a bigger number that goes into them also, and so that wouldn't be the greatest one. The greatest common factor for 8 and 12 would be 4, okay? Or if we had 10 and 40, the greatest common factor, the biggest number I could divide out of both of them, in that case, it would be 10, okay? So when we're talking about a greatest common factor, that's what we mean. Think about all the things I could divide out of it, all the numbers that go into it, however you want to think about it, and you want the biggest number that you could take out of both of them, okay? So when we're talking about factoring out a GCF, or greatest common factor, then usually we're looking at some kind of polynomial. So let's say that we have 7x plus 49. And so what I need to ask myself is, okay, so I'm really just thinking about this 7 and this 49 right now. Okay, so what is the biggest number that I could divide out of 7 that I could also divide out of 49? Okay, so if we think about that, hopefully the number you would come up with is 7. And so I'm going to write a 7, and then I'm going to start a parentheses. Now what goes in the parentheses is what would be left after I divide everything by 7. So if I take the 7x and I divide by 7, I'm only left with x. If I take the 49 and I divide by 7, then I'm left with 7. So this would be 7 times x plus 7. Okay. Now, if you're ever unsure of this answer that you've gotten, you always have a way to check it. So you could check it by taking the 7 and distributing it. Multiply it back out and make sure you really got that same answer that you had before. So 7 times x is 7x, and 7 times 7 would be 49. So 7x plus 49, which is what I started with. That means I must have been right. Okay. So ultimately, though, we were just trying to factor out the greatest common factor. And so this 7 times x plus 7, that would have been our answer. That other part is just where I was showing you how you could tell you were right. So let's try another one. Let's do 8m minus 6. Okay, so we might prefer to see x's, but this same thing works with any variable. So again, I'm going to look at my numbers at 8 and 6. Sometimes we also have to look at variables, but they don't both have variables this time. So if I have 8 and 6, what is the biggest number I could divide out of both of them? And it's just going to be a 2. So 2 would go out in front, start parentheses. And then I'm going to divide everything by 2 to figure out what goes in those parentheses. So 8 divided by 2 would leave this as 4. And 6 divided by 2 leaves that part as 3. So 2 times 4m minus 3. Okay, let's do another one. 5x squared minus 15. So I'm going to think of what I can divide out of the 5 and the 15, and that is a 5. If I divide that 5, then this is going to be x squared minus 3. Okay. All right, let's say I have 10a squared minus 25a. And so this time we want to look not only at the numbers, but also at the variables. So let's look at the numbers first. If I look at 10 and I look at 25, think of the biggest number I could take out of both. So that would be 5. But notice that I also have variables, so I need to look at a squared and a. Well, I could take an a out of both of those parts. So my greatest common factor is not just a 5, it's 5a. So if all of your terms have variables, you can also factor out a variable as part of the GCF. All right, so now that I've started my parentheses, remember we're going to divide like before. 10 divided by 5 would make that 2, and a squared divided by an a still leaves me with an a, because a times a would make a squared. 25 divided by 5 is 5, and a divided by a, that part would cancel out. So this would be 5a times 2a minus 5. Okay, or let's say we have 6x plus 2x, well, 6x squared plus 2x. So in this case, I could take out a 2, and I can take out an x. That would leave me with 3x plus, now notice here I took out this whole thing, but I'm not going to leave that as just 3x. I'm dividing, so 2x divided by 2x is 1. And so I would have to have a 1 there. So that's 3x plus 1. Okay. All right. So let me just show you one more example. And so that would be 8x squared plus 12x minus 10. So sometimes you're going to have something with more than 2 terms. It might have 3 terms. It might be a trinomial like this example I just wrote. So in that case, you have to not just look at 2 places. You've got to look at every single term. So I would look at 8 and 12 and 10. So is there a number that I could divide out of all 3 of those? Okay, that number would be 2. So that's going to be what goes in front of our parentheses. Okay, that'll leave the rest of this as 4x squared plus 6x minus 5.